module is the fourth module that talks about MCDM. Okay, so we had already seen some of the earlier modules where we had talked about that goal programming. We had already talked, right? So okay, let me share the screen. So okay, I hope the screen can be seen now. Yes, can you see the screen?
Yes, sir.
Okay, so we will talk about this module number 4, which is about the multiple criteria decision making. So the criteria and all these things we already understood. But before that, okay, let me rearrange the slides. Okay. So multiple criteria decision making, it is what a general sense. It refers to making a decisions in the preference of multiple, usually conflicting criteria. Okay. Now criteria can be different thing. Let us say if we are talking about allocation of a land there. Okay. Right. So let us say, or let us say that you are talking about you are searching a site, right? Or you are searching a land for let us say for residential purpose. Okay. For residential purpose, and in which you are going to build, we can say it's a job of the developer or the constructor, right? So a developer or a builder will generally see a land and it's his continuous business, right? So he will first of all search a land and then he will develop the land and then he will make up plots and he will develop a colony or apartments, anything like that. Now, while searching the land, obviously he has certain criteria in his mind, right? So what is that criteria? So he might have to talk about what is the price of the land. He has to talk about the connectivity of that particular land, right? You also have to see whether what are the facilities which are available there nearby, right? So something like all those things he had to talk, he need to understand. Then only he can understand about the particular thing. Okay. So accordingly, he will select the particular land. Now, in this case, he have to search a land there, right? So he may have, these are what the features for that, right? So I can say these are what the attributes. We are using the word attributes here. Here are the attributes of the features, right? These are what the features or the attributes of that land, based on which he may have to make the decision, right? And he may have alternatives for that, right? So alternative means he may have alternative. We can call a land A is available to him. Similarly, land B is available to him, and land C is available to him. These are the various sites where all the things had been situated there. सरांना विचारा ना HOD सर शिपायाकडे नाही माझ्याकडे नाही आता नसेल बॅग मध्ये कुठे शोधावं लागेल आता नाही land B and likewise we have the alternatives, right? So we have to select the proper alternatives from that, right? So with that alternative, then how we are going to select that alternative, that will be purely based on these attributes, right? So we have to take into consideration what is the price of land A. So when I say price and when I say connectivity, and when I say what is the facilities there and other things, what about the land A, right? So option A, option B, option C, these are the alternatives. These are the various alternatives which are available there. And you have to select, compare those alternatives based on these things there. What is the price, what is the connectivity, what is the facility. And probably then you have to select the best alternative, right? So you may have to select A or B or C. Based on then you might give some ranking to that. So if you see the alternative, this seems to be first choice, this could be a second choice, and this could be a third choice. But for that, we need some data, and for that, we need some certain procedure for that. How are you going to select the best, or how you are going to make the best decision there? Okay. So that is what this particular MCDM will talk about the things. When you are provided with the several alternatives and the data is given to you, your job is to find out the best one and select the proper alternative based on the facts what have been given to you. Okay, so likewise, in general, MCDM can be further classified as MADM, right? So right now we are using the word attribute here. So generally MCDM and MADM, right? So in literature, these two things have been used alternatively, right? So either you can call it as MCDM, some books call that MCDM, some books call it as MADM. Okay? So from our perspective, both the things are same. Both the things are same from our perspective there. So MADM is nothing but multiple attribute, right? We have multiple attribute and we also have multiple criteria there. And second type of the class is the multiple objectives. So these things we had already talked, multiple objectives, nothing but the goal programming. And this we had already addressed.
Wow.
Getting some disturbance. Everybody please mute yourself. So this is what multiple objective. Then it is called goal programming. So this part has been already covered here. So we will not talk about these things. So we are going to talk only about MADM and MCDM. Okay. So MODM is nothing but continuous. So if we see what is the difference there. So MODS is what? MODM, it's a continuous or integer domain, right? So in which the cases might be the data which had been given to you, that will be a discrete data or a continuous data, right? So data itself can vary. It could be infinity or a large number of choices are there. So alternatives could be more there, more number of alternatives. There are more number of alternatives. And data itself is in a continuous or discrete manner, best of which should satisfy the decision makers' constraints and the preference priorities. Then we have to decide. So we had already seen that if you want to satisfy the goal, we had defined that particular maximum of f of x function that will be p1 into x1 plus p2 into x2, right? So that is what we had seen. So it could be d plus d1 minus or d2 plus. So that things we had seen where p1 and p2 are the priorities, right? So we have to decide the priorities. These things talks about the multiple objective decision making, right? So now what about this MADM? How it differs is that it generally considers discrete data. right? So data which is available there, it is a discrete one with a limited number of predetermined alternatives, right? So there are limited alternatives. So choices are limited here. And solve problem involving selection from among a finite number of alternatives, right? So there are limited alternatives. That is the same meaning there. The same method, what we are talking, its method specifies how attribute information is to be processed in order to achieve a choice, right? So attribute means what is the price, or what we call that facilities on that particular land, right? Or that connectivity. So that will be processed, and then we can talk, right? But requires both inter and intra attribute comparisons and involve appropriate explicit trade-off, right? Now, when we consider price, right? So we are going to consider these things, right? Now the price will be stated in rupees. Price will be stated in rupees, while these facilities, it can be expressed in good facility or bad facility, good, fair, or bad, something like that. Connectivity, we can again, you have to express it, that how many numbers of the buses are coming there, how far is the distance of the railway station or some bus depot, right? So it can be again terms, if you wish, it could be stated in terms of kilometers, right, from airport or from railway station, something like that. Now, if you try to understand, if you try to notice that, you can see all these features, price, facility, attributes, they are, we cannot compare directly with each other there. How can we compare the price with the facilities? How can we compare facilities with the connectivity, or price with the connectivity, right? So that thing has to be taken care. That will be taken care by these proper methods which have been stated in this method, MADM approach here. Now MADM, so obviously this is what MODM. So we are going to talk not about these things. This is what we are already talking. Now if you try to compare MADM, the criteria is the attribute. In this case, the criteria is the objective itself, right? We can have multiple objectives there. Here criteria could be either price or connectivity, right? So then again you have to see what weight has to be given to that price or connectivity, right? Objective and goals are very clear, right? Explicit means it's clear, right? In this case, it may not be very clear, right? Similarly, attributes are explicit here, that is clear, or it is clearly defined, right? I think we need to see the meaning of the word of this explicit. Can you search somebody? What is the meaning of explicit? What is the meaning of explicit? Google search. Yes, can anybody help me? What is the dictionary meaning of implicit? Am I audible to you? Am I audible? Please respond to me.
Yes, sir.
Okay, what is the meaning of explicit or implicit? Dictionary meaning?
So of explicit, stated clearly and in detail.
Right. So explicit means it is clear. Right. We had been given more details there. So in this case, attributes are clear, and it has been stated in a more. Implicit is the opposite of that. That is vague, right? So it is not very pure, very clear, right? So it has to be given in a vague way. Constraints are inherent, and these are again explicit here. Constraints are explicit. It is clearly defined. In this case, the constraints may not be that can be a part of function itself. Now alternatives, how many alternatives are there? That is what finite number of alternatives. So we have option A, option B, or option C. In this case, the infinite number of alternatives are there because that is a continuous function. Right? So uses is for selection and evaluation, and this is generally applicable for the design problem. And these are what? For the selection and evaluation of the various alternatives. Right? So when you when the problem is to select the proper material for the particular application, select the proper site for building, or select the proper type of machine for what particular application, select a proper vendor for our requirements there. So something way it can be used there. Okay, so we will be talking only about MADM. MDM is not a part of right now of our discussion, right? So MADM, something it is also called as MCDM, right? So MADM or MCDM. Now, let us try to understand what is the significance of this particular graph, what they have been used. Now, take an example that we want to talk about the machinability attributes, right? So when I talked about any machinability of a material, so let us say if I take a material, let us say I had talked about the material cast iron, right? Now, what is the machinability of that particular? That machinability attributes can be affected by these are the various attributes, these are the various features of that material. That is what is the grinding ratio of that, what is the I mean how the machinability would be affected for the material cast iron, right? Which are the things which are going to dictate or define the machinability, right? So if I talked about the machinability, we have to talk about the grinding ratio. It is what the normal force, tangential force, or the surface finish, and the dimensional accuracy and the grinding temperature, right? So whenever we do the grinding operation of a particular, let us say cast iron, and if you want to do the grinding operation, so how that material will respond to the machinability, that is how it will help in the proper grinding of that with the help of a proper grinder, and how that particular grinding will happen, that will be dictated by these terms, right? That is what grinding ratio, the normal force. We know that grinding wheel is made up of the several abrasive metals, and whenever the material is being grind there, so there will be a tangential force and there will be the normal force, right? So the force across the material, if this is what your material, the force which are inside the material and the tangential force, right? Because the grinding will be revolving something like this. So it will be revolving like this. So each of those this is a multiple single point cutting tools which had been on which are a part of that abrasive material, and we can have that normal force and tangential force. What is the grinding ratio? How much material is removed? Surface finish, how can it achieve? Dimensional accuracy. So in short, these attributes, if we try to connect with them, each other, right? So when I say one, what is one? One is the grinding ratio. One is the grinding ratio. Now each of them can be related with each other. Now how one is related to two, that could be shown with an graph, which means that one is more important than two. If I show the graph on both the sides, it means that one and two are again dependent on each other. It simply tries to understand the relation between the various attributes there, right? So we can then quantify it later on, but we can understand what is the effect. If I try to understand how one is important compared to two, we will make the pairwise comparison. It is what we are using the word pairwise comparison, and we can talk about how 1 and 2 are. So 1, 2, 3, 4, 5 alternatives are there. Similarly, if we talked about 1, 2, 3, so how 1 is important than 1, right? So we can quantify it, or we can say 1 is more important than 2, by some factor, or one is double important than 2, one is 3 times important than 2, or something like that. So this will be help. Now these are what this has to be worked out, or this can be taken by the judgment of the problem or the decision maker. That has to be taken by decisions at a time there. Because if you are going to select a land, then probably you have in your mind that whether the price is important or whether the connectivity is important, right? So there we cannot say that connectivity is more important than the price. So that purely depends on the judgment of the particular person, or so that importance of that particular, or that comparison of those two attributes need to be understood. For that purpose, these things have been used there. Okay. So we can represent the same thing with the sort of matrix here. So that is what the matrix representation of the diagram. Earlier figure is called diagram. This is the diagram. And when I show it with the matrix representation, that is called matrix. So generally, these are the word which had been used is called GTMA. That is the graphics, or sorry, graph theory and matrix approach. Right. First of all, we make a graph and then we make it as a matrix of that. Right. So matrix representation of the machinability attributes diagram gives one-to-one representation. A matrix called machinability attributes relative importance matrix is defined. This is represented by the binary matrix AXI, whatever the variable you are going to use. AXI represent the relative importance. When I say value of it is the one is there, it means that ith machinability attribute is more important than the jth one. Right? So this is more important. GR is more important than NF. If I see in the opposite way now, if I see NF to GR, there is 0. So NF is not important with respect to the GR. So which is important, which is not important, pairwise comparison that could be stated using this particular relative importance matrix. Right? We can call it as relative importance matrix. Now, there could be several ways of stating all these things. This is what just to introduce you that how this graph theory and matrix approach could be used. Okay. So whenever we try to solve the problem, these things has to be done repeatedly for you there. Okay. So that we had introduced it right now. So in general, MADM, this table we have to make. Right. So when I say whenever you have to talk about the MADM approach, so we have alternatives, right? So land might be selected, purchased, let us say at Borivali, right? So if I talked about the land problem, you have another option at Andheri, right? So you may have an Virar or something like this, right? Or let us say Panvel or something, right? Now attributes, again I told you that attributes could be the price, it could be the connectivity, it could be the crowd which is available nearby, what is the possibility there. So likewise, there could be the several things. And this will tell you what is the particular performance measures, right? Measures of the performance, right? So these things is what, if I talked about alternative, this will talk something about the price which is available in that body. What is the price which is available in the Andheri, right? So likewise, how the connectivity is available at Borivali, how it is at the Andheri. Likewise, all the things are stated. But beside it, it will state the weights, right? So if I say that price is 50% important, the weights, right? Connectivity is given, let us say 20% importance. The crowd might be given another 15% importance, and likewise this will be 5% or something like that. So we have to provide the weights so that we will distribute the which is more important, which criteria, which attribute is more important than the other, right? So that could be, you can say weights, or you can say priorities, or you can name it as per our convenience. Okay. So that will give a total decision table for MADM method there, so that we can solve it. Okay. So there are several methods which could be used for solving these things, MADM approaches. One most simplest type is called simple additive weighing method, right? So we simply use the weighing system or weighting system, right? So another name is weighted sum method, which we can use WCM or some other administrator. This is what introduced by this fellow. Simplest type of MCDM approach. Each alternative is assessed with regard to every attribute, right? So when I say how Andheri is with respect to the price, connectivity, crowd, likewise all the things could be defined, right? So that we can understand alternative. Now this is what one more term is there, need to be normalized the decision matrix, right? So the normalize, if I try to tell you what is the meaning of normalization, just hold on please. Okay, so where are we? I'm talking about what is the meaning of normal. Am I audible? I'm audible. Please respond me.
Yes, sir.
Okay. So when I am talking about normalization, right? So this is what very I told you that how can we consider the price? How can we compare price with the connectivity? Now you can also relate it with here that let us say if you are appearing for CET exam, all of you must be had been appear for that for the entrance exam for our engineering there. So many of you had been coming from HSC background, some of you are coming from CBSE background, and might be ICSE background, right? So ICC, what is that? ICSE something. Okay. Anyway, so or there could be some another boards also there, right? So there could be a state board of now we are talking about the Maharashtra state boards. So there could be a state board from other state also there, right? And then we make the percentage. He got 82%, CBSE got 93%, ICSE got another 95%, right? Now, when we say that how can we compare the HSC state rank, how can we compare this HSC marks with the CBSE mark, right? Because the evaluation methods could be different. And you know that once you fill the form, later on, they will make a merit, right? You will get the merit numbers. So then all of those candidates, they generate the merit numbers, they will develop the merit list, right? And then the allocation and everything will happen. Now, how they are going to make the merit list? Then how should this HSC should be compared with the CBSE mark there? So that data needs to be normalized, right? So that is what the process is there, where you must have heard about the word percentile, right? So we had heard about the word percentile there. So in this case, we do a similar thing where we normalize all the data so that they could be compared with each other, right? So that is what the term which is there. So it just give an overall theory material for the simple additive material which is given in the book by R.R. Rao. Okay, I forget the name. S.V. Rao or something like that, right? So I think he's from SVNIT, Surat who had written that particular book. Okay, so that methods had been very well explained in all of these books there. So this is what they had given, that overall composite performance scores of an alternative that will be determined by using this formula, right? So Wj into Mi, right? So Mi I already told you. So if you simply, let me remove the ink. Okay, I had kept it like that. I cannot remove it now. Okay, anyway. So when you make the ranking there, what it will do, it will multiply Wi with Mi plus Wi with Mi2, M12, like, so W1 into M11 plus W2 into M12. So likewise it will go, and that total will be written here. Right, so that total will be written. That is what the summation of W into P1. That is what it has been done here. So for those all number of attributes, so M is the number of attributes. Whatever number of attributes are there, so that number of attributes we are going to make the calculation weight into that corresponding M value there, right? Right. Now, this is what I told you. So now, if this data is different, right? Now, when the data is might be HSC score and there could be CBSE score, in that case, what has to be done? So it should be normalized. So you will replace that data with the normal data, and we can get this value there, right? Now, this is what the weight of the total composite score of that particular alternative. That is what PI. So likewise, we can work out the composite scores of all the alternatives, whatever things what is available to, right? So that is what which is done there. Now, and one more thing is there. These attributes can be called as beneficial and non-beneficial, right? Now, beneficial you can simply compare with the cost, right? So, or non-beneficial is the cost, and this is the profit, right? Now, obviously, we want to maximize the profit. When I say profit is there, we want to obviously try to increase the profit there. When it is a non-beneficial, we try to minimize that, and this we try to maximize that. Right. So beneficial are all those attributes which we need to maximize, and non-beneficial attributes are those which we try to reduce. Which we want lower is always preferred. In this case, the higher value is always preferred. So those attributes can be called as profit or beneficial or non-beneficial, right? So we calculate those all values there, and how to do that normalization procedure, that we will try to understand from the given data there. So this is what the simple additive methods, SAW. Now, if you simply divide it by the weights, right? Now, in this case, the weights, the sum of the weights, right? So when I say W1 plus W2 plus W3, these are the weights, right? If the sum of all of these weights is equal to 1, right? So it will be in the fraction 0.12 plus 0.18 or something like that. That should be 1. Then we use this particular formula, right? But if that weight is more than 1, relax, right? So if this weight is more than particular 1, then we use this formula, right? That is called simple multiple attribute rating technique. They calling it a SMART. So this is what where we can have. Then we will divide it by the number of weights itself, right? So if the weight is not equal to 1, sum of weights is not equal to 1, right? Then we divide that particular weight. So if the sum of weight is, let us say it is 700. So we will divide this entire term divided by 700, and that will give the performance a composite score for that alternative option. Okay, that is the only difference. Let us say we'll try to understand this particular problem. We'll try to solve it with the what we call that SAW method, which is the simple attribute weighing, right? So if you see simple additive weighing, okay, we'll try to solve it by simple additive. Now we have to select a land. We have to select a land for storing the water, or we want to see the land for the building a dam. That could be also one of the way, right? Now we want to see that on what basis you are going to select the land. These are what the criteria. That we have to see how much amount of rainfall is there in that particular region. How is the drainage systems which are available there, so that we can make that water to flow, or we can say the number of rivers which are connected there, right? How many number of rivers are connected. Uses of land, whether that land is used or unused, or is it for agriculture purpose, or it is of nothing use like that. What is the topography, where it is situated, right? So where it is situated, on the top of the hill, or on some between the mountains, or anything like that. Okay. So these are what the things which you need to consider while these are the criteria when we select that. Okay. Now these are what the criteria considers for the selection, or we can say these are the attributes for that, right? So these are the attributes of that particular option. Okay, let me. Now this is what the data which had been given to us. What does it mean? The land which we have the 4 choices here. We have the 4 choices. That land 1 is there, land 2, land 3, land 4. These are all the different locations of the land. The rainfall might be in mm, how much rainfall is there, or it might be in centimeter, better way. 250 mm will give average rainfall there. Drainage could be the number of rivers which have been nearby for that, right? Uses of land, is it used for, some of the land could be used for, might be we can say in the acres, right? So we can say 7 acres of the land is being used in that particular area, 6 acres of the land is being used in that particular area, something like this, right? Topography is again where it is situated, above the land or above the mountain or something like that. Okay. Now we are calling it as a beneficial or non-beneficial. Now beneficial means we want to see that here we try to maximize this. If we have more number of rivers connected, that is a beneficial. If we have more rainfall which is available in that particular land area, that is beneficial. The topography means how they are, if they are situated at the top of the hill, then that is again a good thing. So likewise, that might be altitude, right? So it can be height of that, or the altitude of the land, right? So what is the height of that line from sea level? We can think about it like this. So we want that if that land is situated quite above the sea level, that is beneficial. Topography means it is non-beneficial. We want that the land is not being occupied by certain people. So if you have less number of the acres which had been used for the land, that should be preferred, because we are not going to, it is not going to affect the land users, right? So this is what we have to select, and then we have to decide how it could be done there. Okay. Now I told you that how can we compare this as centimeters with the number of rivers. If you want to make a comparison in between those variables, then it becomes difficult. So for that we do the normalization. Now this is what the normalized data, what we got it here. it simply does the calculations like this. So if I do I can find out what is the maximum for the beneficial. Right. So what the maximum data from the beneficial, obviously it's 25 here. And for drainage it is 78. And for topography this is 32. Right. Except for non-beneficial, we work out the minimum from this. So minimum from this area is 2 here. Right. So we get these particular values for each of the attributes. Now, while doing the normalization, now we are simply going to multiply what we call that this cell divided by the maximum value. So 25 divided by 25, that will be equal to 1. Then 21 divided by 25, this is 0.84. Again 19 divided by 25 and 22 divided by 25. That will give a composite of the normalized score, right? So obviously, the highest one will be always 1 here. So this is also 1, this is also 1, and 33, this is also 1, right? So you can see this is 1, this is 1, and this is 1. Now, only in case of non-beneficial area, what we do the reverse of that. So we will divide all these remaining atom by the minimum value, right? Here what we do, that particular Aij, any element will be divided by the maximum one, right? And in case of minimum, what we do, we will divide that minimum divided by that particular element, because we want to make all this normalization in the scale of 0 to 1. Every element should fall between 0 to 1. Then only we are comparing that all these things had been falling in the range of 0 to 1. Now we can compare it, because everybody's score is adjusted between 0 to 1. So likewise, if I talked about how we had calculated 0.320, okay, we will go for the minimum one. So this is what the minimum one. So minimum, if I talked about, it has been calculated. Let us how we got it. The first value is 7. So we are going to divide, what is the minimum? 2. So we will divide 2 divided by 7. 2 divided by 7 is 0.285, something like that. Similarly, another element is 2 divided by 6. So we'll get it at 0.33 something. So we'll get this score accordingly. And the rest of the score, what we call this normalized matrix. So this is what we call it as normalized matrix, which will be used to calculate or compare the things now. So now the process becomes quite easier. So again, we are assuming the weights, right? So now this is what we are assuming, or otherwise, if you want to find out, then you have to compare pairwise and then you have to work out those things. That is what we called about that graph theory and GT, the matrix approach. Right? So that will be used to determine sometimes these weights. Okay. So we are assuming weights to be equal. We are assuming that each of them are equal weight. We have to ensure that this total weight should be 1. Summation of this total should be 1. So once you had assumed that weight, now you can find out what is the score for option 1, what is the score for option 2. Right. So option 1 will be 0.25 into each of those normalized score. Right. So into 1 plus 0.25, second 0.858974 plus 0.25, third option, first option, but the third element, that is 0.285 plus so and so, right? So we can work out all of this. So that is what we work out those score, and that had been worked out as this is what the total score. This is what the total score we got it for each of those alternatives. So I can call this as P1, first alternative, second alternative, third alternative, and fourth alternative, right? So this is what land 1, land 2, land 3, and land 4. Obviously, the highest score which had been gained by this particular land for should be ranked one. Now, whenever you want to recommend, the decision maker will first of all select this first land, but if due to some another technical difficulties, he can opt for the second land, right? So we will provide a ranking to all of this. Now we can call it as a simple merit list there, right? So we can now prepare the merit list of all those students who have been appeared for the CET, where they had given HSC score, where they had given CBSE score. So if we normalize all those data, and then probably if the weights could be equal, obviously, in this case, and then we can prepare the merit list, or we can call it as the ranking of that particular site there. Okay, so this way you can go ahead and you can solve the simplest problem there. Okay. Okay, today we'll stop here right now. We will talk about similar such examples which have been given about this MCDM approach. So if you have any difficulty, you can load it now. You can talk to us. The attendance link is the same what had been floated yesterday in the chat box, that you can use it. Any difficulty? Any questions?